What I'm going to say is about infrastructure as a code, and some of you may heard about it, some of you may want to hear about it, and some of you implement it in the production. And I will show how it's implemented in our company SecurionPay, and the whole infrastructure is based on AWS, so the whole talk is about infrastructure as a code in AWS. Oh, it looks like this. You take a big thing and you put the boxes over the fence. Okay, so I'm going to talk about CloudFormation, version control, Ansible, and JenkinsPipeline, and how we are performing, how we are handling the whole infrastructure, and continuous delivery and continuous deployment on the production. Oh, not that. And my name is Szymon, and I work now as a AWS architect at SecurionPay. I'm sysadmin since 2004, DevOps since 2010, and on AWS since 2014, so 5 years now. And I built the whole infrastructure for SecurionPay from the scratch. So what I'm going to say in here is 5 years of gaining knowledge and building stuff, and whole experience is based on 5 years of production product. And SecurionPay, for those who do not know, SecurionPay is a platform where you can pay via us. So you can, when you have a shop and you want to take payments from people, you need to have some kind of secure payment gateway, and we are one of that gateway. So we are in the middle of you and your client and the credit card. So the credit card needs to be encrypted and needs to be stored in a secure manner, and we are PCI compliant, and therefore all the infrastructure needs to be compliant with some. Do you know what is PCI? Some of you, yeah, one guy, yeah. So PCI is kind of guideline that you need to pass in order to accept the payments. And I'll talk about it later. Okay. Okay, the whole agenda is what is infrastructure as a code, our toolset, basics of AWS, which I'll need to explain you because some of the terms in the next topic are based on AWS, and hold the pipeline and our story, how we are performing, what's our uptime, and how it's built. Okay, who of you? I have a quick survey. So I stopped talking, and I'll ask you. Well, maybe you weren't gonna talk, but if you could just raise up your hands, that would be good. So, who of you are humans? Yeah, not maybe all of them. Okay. Good. That's a good start. Okay, who of you are DevOps or DevOps? Okay. Apart from DevOps and DevOps, there's management, there's all the other people over there. Okay, who of you uses cloud? And I assume that this is the AWS cloud? Not all of you. Oh, okay. Who of you use infrastructure as a code? Oh, those are the people that raise up their hands when I ask about AWS. Okay, that's good. Okay. Before you can even start with infrastructure as a code, you need to have some kind of backing management. So management needs to back you up. So you cannot build infrastructure as a code from without the management support. We built SecurionPay from the scratch, and our CTO from the very beginning pushed me to build the whole infrastructure as a code. So no even manual logging to the server, no changing anything without pushing it to Git, or even more, everything needs to be automated, almost everything. So there's nothing that can be done, needs to be done manually if I want to set up a production infrastructure. So everything needs to be done automatically. And next thing is the culture. So whole culture in company needs to be in the specific way, guided in a specific way. So when the developers want to have quick change on the production, they can force you, right? They can force management to do that on the production, but that's not the good way, because if you do it once, you will do that every time. And admins, ops, were willing to automate. So if you like to automate, that's good. If you are lazy, that's even better. And if you like to write scripts and you hate manual interventions, that's good. And it needs to have modern infrastructure. It can be cloud, it can be Kubernetes, it can be anything. But you need to have to be able to use infrastructure as a code, not to handle the hardware stuff or anything like that. Okay. Infrastructure as a code is infrastructure, and it can described in the machine readable definition files, and you can store it in version control. For most of you, probably it will be Git. What's the benefits of infrastructure as a code? It's a cost reduction. It's maybe not that obvious, but after a while, after 5 years, we didn't lose our performance. So we are performing the same way as we were on the beginning. So everything we build anew, we can set up in the code. So no manual stuff. So in the long term is cost reduction. And the speed. So if my CTO asks me to build the infrastructure for a new service, after I gain experience in the infrastructure in the AWS, it's really fast to build it and set it up for developers to test it on the separate stacks, and it's quite fast. And risk mitigation of failure. I'll show you our uptime, and it's measured across all over the world, and it's documented. And of course, the whole infrastructure, you can read how it's built. You don't have to log into a server to check how it's configured. You can go to version control and check how it should be, how it is. Okay, so our toolset, it's GIT, Jenkins, and after a while we implemented Jenkins file, and Ansible of course, and that's next thing is new is Chaos Toolkit. I'll talk about it a little bit, and there's also HashiCorp Packer. And okay, let's start from GIT. What we used GIT for, and it's of course for developers to handle the application code, and also from the infrastructure perspective, we handle our CloudFormation templates over there. So everything is it's done on the AWS. It's done by the CloudFormation. So no manual stuff, no login to console, no CLI, nothing. So everything is in a CloudFormation. I'll talk about it a little bit later. We handle also the deployment scripts, so you can build automation in the cloud, but some part of it's not the way we wanted, so we needed to have some kind of manual scripts. And Ansible playbooks, because you can write everything in Bash, but it's not that easy to maintain after a while. So we used Ansible playbooks. And of course, you can accept merge requests. So in our infrastructure, when when I'm building or adding new stuff to production, first I'm adding it to the CloudFormation, then GIT sends push request to Jenkins, and then Jenkins builds the whole stack on the AWS and AWS. And first it builds it from the master branch, so it builds the production like stack, but from the before the change. Then it performs the update. So for example, if I want to have another server or another auto-scaling group or change in our security group or anything like that, then the first stack is being updated by the change, and during that change we perform some kind of test to be sure that our production stack is changing without downtime. So we are during that deployment we are constantly the second one is working. Okay, constantly measuring how our stack performs. Okay, so Jenkins accepts as I talked Git push actions, and it also it's responsible for starting and stopping environments. As I didn't talk about it yet, but we have like production stack, and it's based on CloudFormation template, and each developer who works in our company can have its own production-like stack. So it's clone of production where he can deploy his code, his code changes to that stack, and he's absolutely sure that it will work the same way as on the production. And it's very important to have this opportunity to work on the production-like stack. Maybe I'll ask you, who of you of the DevOps or Ops are being asked, okay, it works on my environment, why it doesn't work on production? You heard that question, right? Okay, so this environment, so if developers have their own environment, which are the copy of production environment, it's almost the same, almost identical. I cannot think of the question as from the developers why it doesn't work. If it doesn't work, it's most probably their stuff. So I'm good with that. They are not that happy because they cannot blame us, but it's like it's how it works. And during the whole process, we run integration tests on the production stack, on the production-like stack, so on the development stack, and also the unit tests are being performed on the Jenkins. And the cool stuff is on the AWS. You can start, you can have a small Jenkins server with couple of gigs of RAM, and you can and if you want to have big server with big capacity, you just spawn a slave and you can perform tests over there. So the whole stack, whole solution is cost effective. And after that, it performs, it prepares deployment packages, and after that it can deploy that applications. And during the whole process, it sends notifications to our Slack channel. So if anything goes wrong, we have a notification in Jenkins. We don't have to log in and check what's broken there. Okay, but after a while, we needed we wanted Jenkins to be managed by developers. So we implemented Jenkins file, and Jenkins file is like a configuration of Jenkins, but inside the code. And this Jenkins file is a file which is handled by developers, and it's in their code. So they handle the Jenkins file. So if they want simple change in the whole process, like, okay, we want to build that packages, but not in the way you implemented, but in the way we implemented, or add another dependency or anything, they just change it in the Jenkins file, and don't go to me and ask me to change the Jenkins, because they don't have access, and I don't have to manage the access to Jenkins and so on and so on. So everything is in the Jenkins file, and it looks like this. There is a whole pipeline. There are stages. You can this is the really basic stuff. So you can build application, test the application, and the next step you can deploy it. You can have multiple of them. You can have different paths over there. So if the branch on the Git repository is master, you can have like, okay, if the branch is master, you push it to production or anything like that. And in the end, it looks like this. So you have steps. You have the time it takes. When it breaks, it's in the red, like usual. And you can go to the build and check the logs if something is broken. Okay. And as I talked, you can have branch support in Jenkins file. So in SecurionPay, after a while, we implemented a solution that each developer can have its own stack. And before the Jenkins file, I created the stacks for them. And okay, if you want to stop the stack, you can just kill it, and it's not cost you anything. But after a while, they wanted, okay, I want to stack, but for this feature. So I'm working in parallel. So I have two branches, and I want to have two stacks. Okay, I will build you two stacks. But after a while, it was hard to maintain for few developers. So we implemented multi-branch support. So each branch in that solution will have its own environment. So if the developer pushes the code to the feature stack, the stack to the feature branch on the Git repository, it will create the stack which is with the name just for that branch. So for that branch is there is a AWS stack being built, and just that branch is tested on the production-like environment. So usually it's like, okay, one developer works on one branch, but we can have like hundreds of developers, and that's just a matter of increasing the limits in the AWS to handle that many servers. But it usually happens if there's a small change in the code, but we want to test it. Developers just pushes it to the second branch, to the other branch name, and it's tested on the production-like environment. And he can push like 5 times per day, and that's not a big deal. Okay, and to maintain the Jenkins file and AWS and the CloudFormation templates, I implemented some kind of shared libraries. So inside the Jenkins file, you can just load the library, and then you can create stack. It's our purposely built because we need our whole production environment consists of few stacks, few CloudFormation stacks. So the whole solution needs to create some kind of stacks and merge them together. And that was hard to maintain in simple Jenkins file, but you can use iLibrary. Just load the library and just say, okay, I want the stack to have the name like developers or feature, and it's built from the scratch. Okay. Okay, we use Ansible. Ansible we use for few things, because if you have AWS, you can have servers, and on the servers you need to install stuff, and if you need to be PCI compliant like us, or if you want to be secure, you need to harden that server. So every time you set up the server, you need to change stuff, maintain stuff, or install new packages and so on. So in the AWS, you can have snapshots. Snapshots can be transformed to AMIs, and from the AMIs you can start the server the same way like the previous, like you, for example, if you start a server, you install Apache, you can snapshot that server, and from that point you can transform it to AMI, and if you start the server from that AMI, you will have Apache on it. So we use Ansible to manage our hardening scripts. So everything that from the security perspective, like you cannot have a user that is able to write to the that directory, or I need to have Logstash installed on that server. It's handled by AWS and the Packer, which I'm going to talk about it later. And also Ansible we use for bootstrapping instance during provision. So not everything can be handled in AMI. But after a while, having it in a bash, it was hard to maintain. So after a while, I implemented it in Ansible. Okay. That's not in the way. Oh, we use also the Packer. Packer is some kind of tool from HashiCorp that is used by us to install the server, to start the server, run Ansible on it with the hardening scripts, and then take a snapshot of it. And we use it. We could have our own custom scripts, but it would be hard to maintain. Not that way. Go back. So the whole thing is with a couple of lines of code using Packer. And I will go back to the Chaos toolkit. Any questions up till now? Okay, we'll. How much? Yeah. So if we delete it after the test, so it will cost like $10, maybe like that. Maybe less, maybe $1 or $2. I don't know. But we have like really big stack, production stack. It's Aurora over there, big Aurora, and we have Redshift, and we have couple of instances. We have buckets. We have really big infrastructure. So, but each infrastructure is the same way. It's installed in configure in the same way like the production one. So it's not cost effective on the production because it needs to work for 24 hours, but it's cost effective on the development side. Okay, but after a while, there was an almost issuing our production deployment issue. I'm saying almost because we caught it by the surprise, not by the surprise, but we caught it before going into production. But we cannot handle the downtime on our infrastructure, so we needed to a way to perform some changes, some infrastructure, simulating infrastructure failure on the development side. So I implemented Chaos Toolkit, and it's some kind of toolkit that will provide you with the system to shut down some parts of your infrastructure. And in our production stack, in our development pipeline, we use it to fail over Aurora cluster. Aurora cluster is MySQL database or Postgres database, but we use MySQL. So each time on the production pipeline, we check if downtime of or switching cluster from one node to another, so simulating failover of Aurora cluster, will gonna cause the downtime less than one minute. So we are checking during the deployment, during the whole pipeline, every time the developers change something, if the downtime is gonna be less than 1 minute. And I implemented also the failover of Redis instance. So we are checking if, because Redis should not affect our production environment. So during the whole pipeline, I'm constantly sending requests to our endpoints and checking if Redis will downtime of Redis gonna change anything on the traffic flow. If not, that's good. If yes, I will go to developer and say, I'm not gonna go. He will have fail build in Jenkins. Okay, but in Chaos Toolkit we needed to have failure threshold, as I said. Okay, we can tolerate threshold of 1 minute. So we can have threshold of 1 minute downtime, but not more. And after a while, we needed to rate limit that solution, just not to kill our site, development site. But there was not too much traffic of it, and it could kill the production, the development stack. Okay, and the whole simple test looks like this. If you are familiar with Python, you can read it from there. It's not much of code, but it's very sufficient, very efficient to fail over a cluster of Aurora. Okay. If you have questions about the code or anything like that, just ask me after the presentation. Okay, this one I talked about on for the Packer. Okay, and the whole AWS toolset, our toolset, consists of CloudFormation. We base CloudFormation. The CloudFormation is base of everything in our environment. So everything that is being used on production is set up by the CloudFormation, and CloudFormation is kind of template where you describe the infrastructure you want to have in YAML files or JSON files. So you describe, I want Aurora, maybe I have example over there. I want a simple instance, which is gonna be from this AMI image, and I want it to have the security group configured to allow SSH access to everything. And it's like that. The whole code for the sample code of CFN templates, it's like this. So pretty easy to maintain. So after a while, if you change anything on the code, if you want to change anything on the production, you can have your version control to check what is going to be changed on the production stack if I implement it in a way. Okay, but not everything in the CloudFormation is available from the day one. They release the new stuff on the AWS, because they release new production like features on the AWS every week, as I'm aware. So not everything is supported from day one, but if it's not supported, you can write your own custom resources. And the custom resources is a resource in the CloudFormation template where you can use Lambda as a backend. So and in the Lambda you can use Python and Boto scripts, where they will create the resource for you and inform CloudFormation that okay, this resource has been built, and send successful information to the CloudFormation, and then the CloudFormation is going to go forward from that point. And after a while we used CloudFormation, there was a need to have zero downtime, and it's really easy if you use auto-scaling group, So you just say, okay, I want to rotate all the machines in my AWS auto scaling group, and you say, okay, I want those machines to be changed one by one, or all of them at once, or as you wish. And after, so if the server starts, it can signal the CloudFormation. Okay, I finished setup, and everything is right. You can signal the CloudFormation. Okay, or the auto scaling group. Okay, I'm good. You can go forward with. So everything in our production stack, including the deployment of applications, is done by CloudFormation. And in CloudFormation, you can have change sets, so you can see what's going to be changed and in what manner. If, for example, you rename your database, you will lose all your data. So if you rename the database, you say, okay, my database is not case sensitive, and just rename it. The AWS, the change set, can say you, okay, that resource will be deleted, and it will be reprovisioned. You have a question, one? We don't use change sets because we would rather check it on the GIT repository. But if there is a big change on the production stack, I'm just uploading the CloudFormation, and by the console I check how big is going to be changed. Okay. Okay, so cool stuff in the CloudFormation. Some cool features. It's rollback on failure. So if anything goes wrong during the deployment of new infrastructure, or for example, I have my server that is configured in a way, and I want to change something on that server. We use our auto scaling group, and during that auto scaling group rotation, the server needs to send successful information to CloudFormation. So there is a timeout of few minutes. If there is no such a signal from server to CloudFormation, the whole stack will gonna roll back. So after a new server is added, if it's not gonna send successful information, it's gonna roll back. So nothing is gonna happen on the production. You have a second question? That's a good question. If the rollback fails, you have inconsistent state, and you can say, okay, and after 1 hour, 2 hours of rolling back and not unsuccessful rolling back, you have resource that you can leave it as it is, and just the CloudFormation will remove it from its template. Because okay, the CloudFormation is first it will, if you have resource and you configure that resource in a way you want it, and you want to change that configuration, the CloudFormation first it checks if it's gonna need to delete the first resource and create the second one, or it can change the resource without rotating it. So if it's gonna change the resource without rotating it, I don't think it happened that it changed. Okay, if it cannot change that resource, it will gonna just send an error. Okay, I cannot change that resource. But if it's gonna need to create a new one, and it won't gonna create a new one, it will roll back. But if it's gonna roll back and it cannot delete the second resource it created, it will ask you after 1 hour. It will ask you what to do with that resource. There's we encountered a few other not good few other issues with CloudFormation, but it's like a whole story, because after a while we implemented the solution that it's gonna create a new server, that the server needs to send back the request, but the request needs to the server needs to check if it's gonna be attached to load balancer, and there was a mismatch over there, and it wouldn't be there was no possibility to roll back. But in the 90% of 99 of our deployments, when the rollback happens, it won't gonna affect any production server, any production infrastructure. In our case. Okay, as I said, the CloudFormation can handle resource signaling, update policies. As I said, okay, you want to rotate 2 servers out of 10, or you just say how you want to deploy. And the nice stuff in CloudFormation, you can reuse that template. So, for example, if you want to have like your network, and you have template that you describe the network you want it, and you can copy that template in the multiple AWS accounts. Okay, you couldn't do that. You couldn't do that without the AWS API. But again, I'm gonna skip that. Other tools you can use on AWS, it's Elastic Beanstalk and OpsWorks. We are short of time, but so I'm gonna skip that too. If you have questions after the talk. Okay, so how whole pipelines is continuous integration and continuous delivery is like on the picture. So first, a local developer develops the application, then it's gonna push the code to Git repository, and then the Git repository pushes information to our Jenkins, and the Jenkins first it's gonna check the code quality, so the static analysis of code, and during the whole process, if any of the steps fail, the whole pipeline and the whole job fails. So all of the steps need to pass. So after the quality check, the Jenkins spawns a new instance, new server. It's gonna be huge. It's gonna be quite big, but it's just for building the packages and running infrastructure unit tests on that slave. But the big slave, the CPU intensive slave, is up on just when the whole pipeline is running. So after the code is compiled and unit tests are performed, the whole package is uploaded to S3, and from that point, the whole pipeline is gonna create the CloudFormation, so the whole production-like stack on the AWS by the CloudFormation. And then on the using that packages from the S3, deployed on that production-like environment. They're gonna be performed integration tests handled by developers. So developers write tests, and the whole tests are run on not on the production, but on the production-like environment, as I said before. And after that, we are performing the chaos tests, database failovers, Redis failovers. If the update of that package is gonna cause any downtime, for example, if there is a schema of database change during that deployment, we need to be sure that it's not gonna cause the downtime. So the chaos tests are performed, and after that, we want to deploy that, destroy that infrastructure. So whole pipeline takes like 2 hours. but because there's thousands of tests and it's quite CPU intensive, we use web browser tests. So it's quite CPU intensive, and it takes long. Okay, what's implemented in SecurionPay? What we use in AWS. We use a lot of stuff from the AWS. If you want to talk with me after the talk, we are short of time. But hold the solution. So the whole thing. For example, our API. You can see that last year we were down for 2 minutes only. So SLA is 99.99.7. I'm quite happy with that uptime. And as you see the whole thing, and it's screenshot from Pingdom. Whoever you use Pingdom, yeah. So you can say that this this screenshot is not. You cannot say that. Okay, I can show you after the presentation the charts. But it was this screenshot was taken like a few months ago, and our API last year was down for just 2 minutes for whole year.
It's for 1 and 4, right?
Hmm?
It's for 1 and 4, right?
Yeah, for API, just for API. And our achievements, because we use AWS and because we use infrastructure as a code, a very fast PCI certification. It took us 2 or 3 days. We can perform multiple releases per day, and it's not a big deal. After we release the new code, we just go to coffee, and we are sure that nothing gonna break. There is no whole team gathered before your screen to check if everything is fine with the deployment. Everything will be fine. And we can clone production data or production stacks anytime. And what's going to be implemented next? We want to implement load tests, so perform stress tests on the productions. And next thing is chaos with slowdowns, because everything is fine until everything breaks or everything is okay with 100%. But if, for example, there is a network congestion and your packet is gonna flow 10 times slower than usually, you aren't gonna know how your infrastructure is gonna, or the whole platform is gonna behave. But that's next. Okay, that's all from me. So now it's time for you to ask questions if you would like to.
Okay, any questions? Okay, take a sec.
Are you doing any canary deployments on infrastructure? Or I know that some changes are atomic and needs to be done like all infrastructure, but can you deploy all? You deploy production all at once, like?
Yeah, we need to do that. Yeah, because in the financial world, if we release feature, there's either gonna be a feature switch or we deploy it. So we do not do canary releases, because if we change something on the production, it needs to be like sharp line between one version and another.
Okay, thank you.
But you can do that with the CloudFormation and auto-scaling group. As I said, rotate one server on out of 2 or 10% of the servers.
Any further question? Okay.
Hi. So
Hi.
you said that you're using the snapshotting functionality in order not to install everything from
Yeah.
scratch every time. Did you experience any problems with configuring networking
During the snapshot or after that?
after that when you're just starting a new,
No.
let's say, stage?
No,
It's-
because in AWS, you configure, because the network is really simple. You have just one interface and you just push the traffic through the one interface. But the snapshot consists of, okay, I want just one interface on that server, and next time it's boot up, it's not gonna have the IP addresses of the or the configuration of the snapshot. The snapshot won't gonna consist network configuration.
Okay. Okay. Thank you.
So next time the AMI is used, it's gonna get the DHCP the configuration from DHCP.